Alright, question 3 of the probability sample paper. Emma was given a set of 6 different keys to her new house. Some joke by the realtor. One of the keys opened the deadlock on the front door, and a different key opened the door lock on the front door. So there was 2 different locks on the door. The deadlock, I guess that abbreviation won't work, a deadlock, and then the door lock. So like a deadbolt and a door lock. Emma did not know which keys were the correct keys for each lock, and was able to open both locks after only 4 key attempts. So she took 4 attempts with different keys to get the doors open. Emma's friends thought this was a low number of key attempts and wondered what the process Emma used to find the correct keys. So she designed and carried out a simulation process to estimate how many key attempts it would take before both locks would open, using trial and error process. So try a key, see if it works. For trial and error, the assumptions that we make here is that a key was selected at random to try to open the deadlock. So we get the top lock if you want to think about that first. So a key is tried on this one. Once Emma's tried a key for the deadlock, she did not try it again. So if it doesn't work from the deadlock, she doesn't use it. And once Emma found the correct key for the deadlock, she removed this from the key set and then tried the same process with the door lock. So what she does is she's got 6 keys, 1, 2, 3, 4, 5, 6. She tries all 6 of them on the deadlock first. When she's got that key found, she takes it out, and she'll only have 1, 2, 3, 4, oops, that's 5. 1, 2, 3, 4, 5 keys left to try on the door lock. So again, she uses all 6 if possible. Well, she could potentially use all 6 keys on the deadlock, finds the right one, takes it out, and then only has 5 to choose from on the door lock. So the results of the simulation are below. Again, this is the case where it only took 2 attempts. She got the deadlock key right on the first try, and then she got the door lock key right on the first try as well. And so the frequency of that happening would be 29. We can see that the frequency increases. It's most around about 7 attempts, and then tails off again. So again, this is basically had to try every single key before she finally figured it out. So we want to know, calculate the theoretical probability of a person using trial and error. So remember, this is the experiment part of it, or the simulation, and the theory is just thinking through it, of trying more than 2 key attempts before both locks are open. Compare this probability with the results from the simulation. So remember, with probability, I could have probability of 2 attempts and then everything else, so probability of more than 2 attempts. So these are complementary events. This covers everything. So I could have that they get it in 2 tries, or everything else, that it takes more than 2 attempts to make it work. And if I add those 2 things together, that's every possibility available to me, and that's equal to 1. Now calculating 2 attempts is probably a lot easier than calculating 2 or more attempts, because that means I have to calculate 3, 4, 5, 6, 7, etc. So if I'm smart about this, I can say 1 minus the probability of 2 attempts will get me the probability of more than 2 attempts. So, in theory, the probability, well, we'll say 1 minus, the probability of getting it in 2 attempts means that they get it right on the deadlock first. Remember, we've got a deadlock with 6 possible options. We find the right one, and we've got the door lock, and that leaves us with 5 possible options because we take the deadlock key out. So I can go 1 minus, the probability of getting the deadlock right on the first try is 1 out of 6. And then the probability of getting the door lock right on the first try is 1 out of 5. So if I put these 2 things together, I'm going to get the probability of more than 2 attempts. So that's everything else. And when we do this up, we get 0.9667. So that is my probability for 2 or more attempts. So now the question for us is to compare this, the theoretical, to the experiment or the simulation. So if you add up the total number that she actually attempted here, you get 1,000 attempts. And we can go through that same process. that the probability of more than 2 attempts is going to be the probability of 1 minus 2 attempts. So we'll try it for, this is the theory, and we'll try the simulation. So that's 1 minus, the probability of it happening in only 2 is 29 out of 1,000. And we do this, we get 0.971. So this is in experiment or simulation. So the simulation is slightly higher, but not by much. That kind of rounds to 97%, and this rounds to 97%. So the results are similar. Simulation is slightly higher than the theory. So it could be that, because again, she's doing this simulation to try and figure out if it's possible her friend did it by trial and error. So the theory for 2 or more attempts is matching pretty well to the simulation of 2 or more attempts. So her model, remember she's had to create a model to do this simulation, is seeming to match at least this part of the theory pretty well.